Hello everyone, welcome to the 10th tutorial class on artificial intelligence and fuzzy logic. And this class will be presented by myself, Dr. Sudip Mandal, Assistant Professor of Department of Electronics and Communication Engineering from Jalpaiguri Government Engineering College. So coming to the content of this class, in this class we shall discuss a very important topic, that is the backpropagation neural network, and we shall observe the future of this backpropagation neural network, and after that we shall learn the training process of backpropagation neural network and why do we call it as backpropagation. Okay. And at the end we shall also discuss uh, an example that will help you to understand the backpropagation neural network or backpropagation learning algorithm with more clarity. Okay, so let's start backpropagation network. Basically, if the training data for the artificial neural network is very simple, where there is no noise or and the data is uh, linear in nature, so in that case, we don't need to use uh, hidden layer in between input and output layer. Okay, but in real world, we always faced a situation where data is incomplete and noisy. Okay, so for that case, if you want to make prediction and if there is some kind of missing information in the data, so there is all it is very difficult task for the prediction. Okay, so in that case, backpropagation neural network will work very efficiently. Okay, so basically a backpropagation neural network consists of at least three layers in the artificial neural network. First of all, an input layer, and second layer is the intermediate hidden layer, and the number of hidden layers may be more, but there should be at least one intermediate hidden layer, and there should be obviously an output layer. Okay, so backpropagation neural network consists of three layer: input, hidden, and output layer. Okay. Oh, so now coming to the next slide. So uh, typically, these units, that means unit, hidden layer, and output layer, are connected in feed forward fashion. Okay, that means uh, input units fully connected to the units of the hidden layer, and hidden layer units are connected to the output layer fully. Okay, so when a backpropagation network is cycled during training, an input pattern is propagated forward direction. That what is the forward direction? Forward direction means from the from the input end to the hidden layer, and from the hidden layer to the output layer. Okay, so the that means a input pattern is propagated in the forward direction to the output end. Okay, so via input to the hidden and input hidden to the output words. Okay, so and then the output of the backpropagation network is interpreted as the classification decision. Okay, so output will give you some kind of decision or some kind of predicted value. Now it is quite possible that the value does not match with the target value. Okay, calculated value does not match with the targeted value. That means there is some kind of error. Okay, so in case of backpropagation network, learning occurs during a training phase, and there are some simple steps during the learning. Those steps are given below. So for each of the input pattern in a training set is applied to the input unit and then propagated in the forward direction, as we already mentioned. Acha. And next, the pattern of activation arriving at the output layer is compared with the corrected or target value pattern to calculate an error signal. Okay, and this error signal for each of the such target output pattern is then back propagated from the output to the input in order to appropriately adjusted the weight in each layer of the network. Okay, that means whenever there is an error occurred at the output end and the error is sufficiently large, then that error will be propagated backward direction. That means initially it will be propagated backward direction, that means from output end to the hidden layer, and after that, based on that error signal, the weight between output layer and hidden layer will be adjusted, and next this error again will be propagated from the hidden layer nodes to the input layer nodes, and based on the error signal again, the weight between hidden layer and input layer will be again adjusted. Okay, and after that, when and like this way it will be continued for the each of the training pattern input pattern. And when and if for each of the cases we shall observe the error rate. Okay, and whenever it will be sufficiently low or below the threshold value, below some kind of threshold limit, and at that time iteration will be stopped, and we can say that the optimum weight can be has been achieved, so that we can get the maximum classification accuracy or prediction best predicted value. Okay, so after a backup network has learned the correct classification for a set of input, it can be tested on the second set of input to see how well it classify on untrained pattern. Okay, so initially we can train the artificial neural network using backpropagation algorithm, and after that we can test that model on the another set of untrained data set, so that we can validate the trained model. Okay, so come to the back propagation training. This one basically schematic of the back propagation training. You can see that our model worked like this way. So initially during the training, at the initial stage, we always calculated the error between that calculated output and with the targeted output, and we shall check, and based on that, and we shall check that if that error is minimum, or mm, error is low compared to a threshold limit, and if this condition has not been satisfied, that means error is quite sufficiently large. That means based on that error we need to update the parameters. Parameter means weight and bias, and like this way, the process will be continued until we get the error as minimum, or the error reach its threshold limit. And after that, if that condition has been satisfied, our model has been trained, and we can tell that back propagation neural network has been ready to make the prediction. Okay, here there is some characteristic that need to be mentioned for the backpropagation algorithm, and we should remember that backpropagation algorithm is based on the gradient of the error function. That means we need to calculate the error, the gradient of the error. That means if the error is defined by the e, so error will be d by dw, where w is the weight. Okay, so we should observe the gradient of the error function. And backpropagation can be written as a function of the neural network, and backpropagation algorithm are a set of methods used to efficiently train artificial neural network following a gradient descent approach. Okay, now the main feature of the backpropagation are the iterative, recursive, and efficient method through which it calculates the updated weight to improve the network until it is not able to perform the task for which it has been trained. Okay, and the derivative of the activation function to be known at network design time is required to backpropagation. And before going to the next part of the uh, backpropagation algorithm, that means the before going to the details stepwise procedure of the backpropagation algorithm, so let's consider a scenario like, suppose uh, I have been reached a railway station. Suppose consider Jalpaiguri road, but I don't know in which direction is the Jalpaiguri government engineering college. Okay, so what can we do? We can go to a certain direction and check, and check, or we and ask that it is correct direction. Okay, and if that is not correct direction, so we need to go to the in backward direction, and we need to change the direction, and ultimately again we need to go to the right direction. So that means back propagation. That means we need to go to the more forward direction up to certain distance, and check whether it is correct direction or not, and if that is not if there is an error, so we need to correct our direction, and ultimately we can reach our Jalpaiguri Government Engineering College. So that is the back propagation. That means for each of the cases we will go similarly. In case of neural network, we will go to the forward direction for each of the input pattern, and we will get some kind of calculated value, and we will check the calculated value with the target value, and if there is satisfactory amount of if there is high amount of error, or then we need to update the weight and bias. So for that direction, for that for that purpose, we need to move in the backward direction. That means the error will be propagated in the backward direction from output into hidden and hidden to the neural input layer of the neural network. And based on that error, respective weight and bias between output neuron and output layer and hidden layer, and the weight and bias between hidden layer and input layer will be updated gradually, and those algorithm and those equation will be elaborated in the upcoming slides. Okay, so coming to the um, this one basically give you a multi-layer feed forward back propagation neural network. You can see that here first one denote, actually denote this one 2 up to l number of there is I number of nodes in the input layer, and this one is the basically output layers. There is n number of output nodes, so 1 2 up to n. So o1 o2, these are all the output nodes, and IO, IY1, II2, IL all are the input layer. And in between there should be at least one hidden layer. You can see that here there is one hidden layer. That is the one hidden layer. So that is the IH1, IH1. Sorry, yes, hidden layer one, hidden layer node 1, 2 up to M. Okay, so there is m number of nodes in the hidden layer. Okay, so you can see that input to the input nodes, sorry, yeah, for the node number 1 in the input layer, for the input pattern, the output is O11, that is going to the uh, hidden layer, sorry, hidden node 1 via the weight V11 V21, like this way. And the weight between hidden layer and the output layer are W1, W21, WM1, WIJ, like this way. Okay, and there should be some kind of n number of input and output data. So you can see that for I1, I2 up to IL, there is for past data set, this one the input case, and for that input we get the output as like O1, O2, and ON. Okay, like there may be n number of data set, and it can be used for the training of the respective backpropagation neural network. So coming to the stepwise procedure for the backpropagation algorithm. So first step here, it has been written as that normalize the input output with respect to the maximum value. It is very common approach where we can normalize input output with the maximum. There is nothing wrong with that. And for each and next what we can do, that for each of the training pair, mm, for L number of input, we define the total input by a matrix I1. Okay, and for the n output given O matrix. Okay, so then we can assume that the number of neurons in the hidden layer in between 1 up to 21. It has been observed that for any kind of classification purpose, 20 to 20 number 1 hidden nodes give the satisfactory accuracy. So we can take any number of values of hidden nodes in between 1 and 21. And next, coming to the next step 3. Next, let V matrix define weight of the synapse between input neuron and hidden neuron. And next, let weight matrix define the weight between hidden neuron and output neuron. Okay, and so after that we need to initialize the weight value to a small random value in between -1 to +1. So VO, that is define the random weights, and OWO, that is also define the weight random weights. Okay, and initially next we define the delta V, that means change in the weight in between input neuron and hidden neuron, and delta W, that means change in weight between hidden and output neuron, are all 0. Okay, next for generalized problem, lambda can be assumed as 1 and threshold value as 0. Okay, now coming to the step 4. What we can do, that for training data we need to represent one set of input and output as an input pattern. Okay, so present here we present the input by I1. So then by using the linear activation function, the output of the input layer may be given as O equal to I. This is quite similar, identical. You don't need to bother about that. And next we need to compute the output of the uh, output at the hidden layer. Okay, so I'm going to calculate the corresponding value, and that is given by IH equal to transpose matrix of V into OI. Okay, that means we already know that how can we calculate the sorry, output of an accumulator, like V1 I1 plus V2 I2 plus V3 I3, like this way. So that can be simply achieved by matrix multiplication. So so in matrix format it is simply written as like this way: V transpose T multiplied by O. Okay, so O is actually for each of the training pattern. Sorry. Next, it will go through the activation function. Basically, in for backpropagation neural network, we are using sigmoidal function, that is 1 by 1 plus e to the power minus x. So IH will go by this, and we get OH. OH is nothing but 1 by 1 plus e to the power minus IH. In step 7, we need to after that, what will happen? So we are getting this value OH1, OH2, OHM. Now you can see that all these OH1, OH2 are going to the output node via with W1, W21, like this way. So again, uh, yes. So we need to compute the input to the output layer. Okay. So what will be the that value? So that will be again like O1 into W11 plus O2 into W12, like this way. So just we calculating, we expressing that equation by matrix format: IO equal to WT into multiplied by OH. Okay, and after this one, basically the output of the accumulator. Okay, so without writing the individual equation for each of the node of the output layer, we are just you can express all the equation by using this simple matrix format. Okay, so that is the advantages. So next, what we can do, obviously that output of that accumulator of the output node will go through again the sigmoidal function, and output of the activation function will be OO divided by equal to 1 by 1 plus e to the power minus IOJ, sorry, IO. Okay, and in step 9, so after that we are getting output calculated output. Basically this one is nothing but the calculated output. So what we can do next, we want to calculate the um, total error. Okay, so that is nothing but the mean squared error, root mean squared. You can use either root mean squared error or mean squared error also. So calculate the error using the difference between network output and the desired output for the jth training set, and we get the EP. Okay, so you can see that Tj is the actual target value, O is the calculated value, and N is the number of uh, training set. Okay, now step 10, at the find a term that is tk minus OK into 1 minus OK. So you need to remember this value. Actually, there is lots of equation from where we can get this value or equation. Okay, so just for now, just remember these terms. So you need to calculate a d whose value is tk minus OK into OK minus 1 minus OK. So next, in step 11, we calculate the matrix as like, that is multiplication of OH matrix into D, and next step is nothing but the updation of the weight matrix, that means in between output layer and the hidden layer by this. So the uh, delta W t plus 1, that means the at the next iteration, that is nothing but alpha into delta W plus eta into Y. Okay, so Y is here, alpha is 1, and in this one is the learning rate. So you can check it, you can use it for your own. Next we are using calculate this error E value. So we are getting the actually change in the weight matrix in between hidden and output node. Next we need to get the change in difference or uh, difference in weight of in between output and input node. So for that purpose we need to calculate this matrix equal to W into D, then D star equal to EI OHI 1 minus OHI, and next we need to calculate this X matrix, which is nothing but OI into D star. Okay, and after that we are getting the change in the weight in between hidden and input layer, that is defined by delta vt plus 1 equal to alpha into delta vt plus n into x, sorry, eta into x. Okay, so as per the equation, so vt plus 1 equal to vt plus delta vt plus 1, and wt plus 1 equal to wt plus delta v delta wt plus 1. Okay, so this is the final updated weight. And next we will calculate that error rate. So we already calculated the net error, and if we define by the total number of training set, that will be the find error, total error, sorry, or error rate. And if it is in between less than the some kind of threshold value or tolerance value, we will stop. And if it not stop, so what will happen? So the iteration will continue, and after that, when the limit has been reached, then we will get the ultimate updated value of the weight, and we can say that the model has been trained. Okay, so then the algorithm is has been stopped, or end of the algorithm. So note, you can that the implementation of this algorithm step by step 1 to 17, assuming one example for training method is illustrated in the next section. However, we are already here, we are written like how this equation has been coming. So it is basically quite complicated here, but we should remember this term if you want to implement in your, so like using MATLAB or Python. So just follow these rules or equation. But let's see that how backpropagation algorithm works if you consider a real life example. So you can see that we are considering this example like two input and two output. uh, so I1 I2, these are the two input, and O1 O2 are the two output. In between them there is hidden layer H1 H2, and W1 W2 and W3 W4 are the weight in between input and hidden layer. W5 W6 and W7 W8 are weight in between hidden and output layer. And B1 B1 are the uh, bias value, and b2 are the weight value. And the initial training data set has been given here. So 0.05, 0.10. So for this value, the output should be 0.01, 0.99. So this is another target value. Okay, and this value like 0.15, 0.20, 0.25, 0.30, like all these are the basically initial value. Okay, so we are assuming that the initial value of this weight and bias are given by this. Okay, so let's see how it will work. So forward in first, we already know that forward propagation, that means for each of the training pattern, the inputs will propagate in the forward direction. So we need to calculate the output at head node h1. So how can you calculate net h1 equal to wi1 plus wi2 plus b1? Okay, so this one is the 0.3755. So output of the h1 is sigmoidal function. So we are getting this value, and similar way we are getting output of the h2 as like this value. Okay, and we will repeat this process for the all of the output layer neuron. So similarly for h2 we will again calculate, or h3 for we will again calculate. Okay, so next all this value, that means h1 h2, the output of this value are going to the O1 and O2 node. Okay, so we are calculating the output for the O1. So net O1 equal to W5 into out H1, W6 plus out H2 plus B2 into 1. So, and we getting this value. And again there is some kind of activation function, that means there is sigmoidal function. So this value going to the activation function, we are getting ultimate way out ultimate output O1 as 0.75136 in spite of 0.01, and we are getting output O2 as 0.77 in spite of zero point 0.9. So obviously there is error, so calculate the error. So the total error is can be written as like 0.01 minus 0.75. This is for the output node O1, and for the error for O2 is 0.02, and total error can be U1 plus E2, that is the 0.29837. Okay, so this is the error, and we are checking that if error is low or not, or below the tolerance limit. So if that is above the tolerance limit, so what we can do, we need to move in the backward direction so that we can adjust the weight and bias value, and our aim is to reduce the error step by step procedure or during the iteration. So let's check how can we calculate or how can we update the weight value. Basically, in this example we are just show you how w5 value will be changed, okay, in detail. Okay, so but let's calculate the error, calculate the rate of change of error w rate wrt with respect to w5. So we total delta total divide by sorry so delta e total by delta w5 is nothing but delta e total by delta out O1 into delta out O1 by delta net 1 and into delta net O1 into delta W5. As we cannot make a derivative direct with respect to W5, so we are making partial derivative like this way. So our aim is to calculate all of this term, each and individual term separately. Okay. So since we are propagating in the backward direction, first thing we need to do the calculate the change in the total with respect to output O1 or O2. So that you can see that delta E total by delta O1. So delta E total by delta out O1 can be written as like this, target O1 minus target O1, and we get this value. So first term we are getting. Next E total, okay, next 0.75507. Okay, so next we want to further propagate. That means we want to calculate, we want to further propagate back to calculate the change of output one with respect to its total net input. Okay, so this value can be nothing but like this way, 0.81867. So we already know the out O1 equal to 1 by 1 plus to the 1 net O1. So we can see that here it is been right out O1 into 1 minus out O1. So we'll find that there is a similar way representation. Yeah, O okay minus 1 minus O okay. Okay, so basically that is the simplified version, but here you can see that the how this term has been reached. So if we make derivative of this 1 by 1 plus e to the power minus x, so we ultimately guess what out O1 minus 1 minus out O1. So like this way it will get. So after that, so we are getting yeah. So let's see how much next term is delta net 1 by delta W5. So this one is the net O1, and if we make derivative we are getting this value 0.5932. So ultimately del E total by del W5 equal to this. So we are getting 0.082165. Okay, so if I'm multiplying this value with this value with this value, so total three term has been multiplied and we are getting this value. So this is the basically uh, updated value. Okay, so let's calculate the updated value of W5. So W5 plus, that means the value in the next iteration will be W5 minus n delta E total by delta W5, that is W5 equal to 0.04 minus 0.05 multiplied by 0.08 this term, and updated W5 value will be 0.3589. So you can see that initial value was zero point 0.4 and but the updated value is 0.35. So similarly you can proceed or you can update all the weights of the network, and after that we'll again propagate the forward and calculate the output for the next input pattern. Okay, and we calculate the again error, and if the error is minimum we'll stop right there, but if does not minimum or there is some kind of the value is some above the tolerance limit, so we need to again propagate in the backward direction so that we can again update the weight and bias value, and this process will be continued until we can get the minimum value. So I hope with this example the back propagation algorithm is clear to you. Here we have studied an important concept of back propagation neural network training. So the simple structure is like that: initially initialize the weight and bias, and we need to repeat the process for each of the training pattern and until the error has been acceptably low. Okay, and there is lots of mathematical equation. So just keep your head cool, and you need to follow the stepwise process one by one, and we can easily get the updated value of the weights. These are the few references that has been used for the making of the slides. So thank you. If you have any problem, please post them. Thank you.